Cyclin-dependent kinases regulate the cell cycle, but such regulatory function depends on a CDK associating with a cyclin subunit. CDKs themselves are also regulated both positively and negatively. Without cyclin bound, the catalytic active site of a CDK is located in a deep cleft between the N-terminal and C-terminal domains, where it is blocked by a flexible T-loop. Both cyclin binding and phosphorylation are required for activation of CDK enzymatic activity. Negative regulation of CDKs is important for growth regulation during G1 and G2 phases of the cell cycle, as well as cell cycle arrest in response to DNA damage and anti-proliferation signals. CDKs are inhibited by phosphorylation of residues adjacent to the ATP binding site and by binding of inhibitory proteins.
CDK complexes are inactivated when bound by small inhibitory subunits of cyclin-dependent kinase inhibitor, CKI, and inhibitor of CDK4, INK4. INK4 inhibits CDK4 and CDK6 by distorting CDK structure such that cyclin cannot bind. Without the small inhibitory subunits, cyclin can bind to form the CDK-cyclin complex. However, P27 can bind to the CDK-cyclin complex and block ATP from binding.
For complete activation of CDK2 cyclin A, CDK activating kinase, or CAK, must phosphorylate the CDK cyclin complex because phosphorylation stabilizes the CDK cyclin complex. This positive regulation of CDKs is important for cell cycle progress. During G2 phase, protein kinases MIT1 and WEE1 phosphorylate the CDK1 ATP binding site, thus interfering with ATP binding and hydrolysis. These inhibitory phosphorylations, however, can be reversed by CDC25 phosphatases.